Okay, now let's start with question 4a. Explain any 4 common feature engineering techniques for continuous or categorical data. In my slide, I have shown 4 techniques along with real examples from both crime datasets and student datasets. Let me walk through each technique in detail. So first is binning, means converting continuous numerical values into range-based categories. For in the crime example, we can see that less than 1 year, between 1 year, 1 to 7 years, and greater than 7 years. This is extremely important in legal analytics because dowry-related violence is statistically highest within the first 7 years of marriage. So binning helps the algorithm understands this risk, categorizes instead of treating the marriage duration as normal number. So in student example, we can see for student I have shown total internal marks being binned into low for less than 40, medium for 40 to 60, and high for greater than 60. This way, instead of working with the continuous marks, we convert them into categories that indicate performance levels. This simplifies prediction tasks and help us model detects learning patterns more easily. So second is one-hot encoding. This technique converts categorical variables into binary columns. In crime example, you can see the relationship with accused field has categories like husband, mother-in-law, father-in-law. These categories cannot be used in algorithms directly, so one-hot encoding converts them into binary indicators like husband is 1 or 0, mother-in-law is 1, 0, father-in-law 0, 1. This helps the model understand the category without assuming any numerical order. In student example, we can see video 1 is yes, video 2 is yes, video 3 is yes. Each of these becomes a separate column, so the model understands exactly which assignments were submitted. Third is interaction features, means combining 2 or more features to create a stronger predictor. In crime example, I have shown dowry demand into burn injury. This combination becomes a very strong predictor for classifying cases into BNS 80, dowry death. Individually, both features are useful, but when multiplied, they capture a much stronger pattern. In student example, attendance into average test into all videos submitted, it becomes a super feature. This captures the combined effect of consistency, performance, and engagement. Such interaction features usually increase model accuracy and significantly. Fourth is scaling. Scaling transform numerical values. They have mean 0 and standard deviation 1. This is necessary for algorithms like logistic regression, SVM, and k-means. Crime examples are in my slide. I have shown victim age is scaled, number of threats is scaled. Scaling ensures large values like age do not dominate small values. So in student example, for all student performance prediction, I noted that all marks and attendance scale before logistic and SVM. This ensures equal contribution of all features, improving training stability and accuracy. Now, so these 4 techniques, binning, one-hot encoding, interaction features, and scaling, form the foundation of effective feature engineering, both crime analytics and student performance prediction. Now let's get started with question 4b, which is, okay, what is sampling from a distribution? Describe inverse transformation sampling or Monte Carlo sampling with an example. Okay, in my slides you can see all 3 concepts using real example from SIR datasets and student marks. So what is sampling from a distribution? Sampling forms distribution means generating new artificial data values that follow the same statistical pattern as the original data. In my slide, I have shown if victim age follows a distribution, we have a mean equal to 28, standard deviation is 8, and roughly normal shape. This and this. Then sampling from the distribution might generate ages like 27, 31, 35, 18, 29. These values are not copied, these are synthetic, but they follow the same statistical behavior. This technique is used for simulation, bootstrapping, synthetic data generation, Monte Carlo risk analysis. Now, moving on to inverse transform sampling, it is a method that allows us to generate samples from any distribution as long as we have its CDF, the cumulative distribution function. So steps to calculate it are generate a uniform random numbers U, uniforms from 0 to 1. Compute the x equal to f inverse U, where f inverse is the inverse CDF. X equal to f inverse U, in case if you aren't able to see that properly. So on the slide, I've shown the cumulative distribution of time since marriage. 0 to 1 years is 0.20, 1 to 3 years is 0.55, 3 to 7 years 1. If u equal to 0.62, we find where it fits. 0.55 is less than 0.62 is less than 0.90. Category is converted, we get a category as from 3 to 7 years. So the sample time since marriage around is 5 years. This creates realistic synthetic FIR profiles. So moving on to Monte Carlo sampling. Monte Carlo sampling means repeatedly generating a large number of random samples from distributions to estimate outcomes, probabilities, or risk. You use this when systems are complex, mathematical formulas are not possible. You want to simulate many future scenarios. For example, FIR BNS 80 prediction. Our goal is to estimate probability that a new FIR is BNS 80, dowry death. So step 1, estimate the feature distributes. Dowry demand is yes, probability 0.32, burn injury 0.12. Time since marriage distribution is given above. Gender is 78% female. Relationship with distribution with accused. Training data we can see in training data distribution. Second step is run 10,000 simulations. For each simulation, sample dowry demand Bernoulli from Bernoulli. Sample injury type, sample time since marriage via inverse transformation, sample victim age, feed all sample values into IPC BNS model, count how many predictions say BNS 80. The final ratio gives the estimated probability. So, in summary, sampling from a distribution allows us to create realistic synthetic data, and inverse transform sampling allows us to sample from any known distribution. Monte Carlo sampling allows us to simulate thousands of scenarios to estimate probabilities and outcomes. So, hope you enjoyed this video and found it informative. We'll see you in the next one. Thank you.